Welcome back. Today, in front of us, we have a small display turntable that I built using some basic parts and 3D design. This can be a great classroom project that helps your kids become engineers and more established with coding. Generally, all of my classroom projects fall on the scale of 1 through 5, with 1 being the easiest and 5 being the most difficult. Think of it as this way: a project rated as a 1 can be an easy whole class project that takes minimal time and is used as a starting point. Most of the time it can be completed without even your direct assistance. However, a project with 5 means it's the most intensive and requires a host of skills. I usually assign these as independent or small group projects for enrichment purposes. Direct intervention may be necessary, but generally it's up to the students to complete the entire project by him or herself. Anyway, this display turntable would be a 3. Let's look at the turntable. As you can see, the base is designed using a CAD program and has been printed on a 3D printer. It's using a simple DC motor connected to an Arduino that controls the speed with a potentiometer. There are 2 LED lights that indicate the speed. Lastly, the tabletop is made out of a simple foam board. Why are we making this? That's an excellent question. First, this table is a cool way for kids to display their 3D printed projects. Second, there's a host of skills that are required to complete the project that give these kids the right exposure to coding, circuit designs, soldering, and attention to detail. Before we get started though, let's take a moment to thank today's sponsor, BioGalactic Teeth Paste. Tired of brushing one tooth at a time? Then it's time to step into the future with BioGalactic Teeth Paste. This specialized formula of water, waffle batter, and sugar brushes all your teeth in half the time. 4 out of 5 dentists we've paid recommend this toothpaste for their clients. Galactic Toothpaste. Your teeth will go out of this world. Warning: may cause rapid tooth decay and lightheadedness. Let's get started. Here's the items we will be using today. 1 small DC motor, an Arduino NANO, 1 potentiometer, 1 rectifier diode, 3 220 ohm resistors, a project component board, 2 LED lights, 1 red, 1 green, 1 3D printed base, 1 3D printed motor base, and 1 piece of foam board. Altogether, these parts will cost about $15 to $20. Now, I've already designed the base for this project and printed it along with the plate to attach it to the motor. A link for the STL files can be found in the description below. We're using the Arduino Nano because of the size and because it can be ran using a common power supply with a micro USB port. The only downside to using the Nano is that it doesn't come with the pins soldered on, so we need to do that right now. Now that the pins are soldered onto the Nano, we need to make the circuit board to put the transistors and resistors on. Ideally, we want to make the circuit board around the same size as the Arduino so it can fit in the chassis. This generic board can be cut using a simple rotary tool. The board will need to be around the same size as the Nano, 43 millimeters by 18.5 millimeters. Now let's cut this really quick. Make sure to wear your goggles, not your Googles. Now, this is how students would wire it up using a basic breadboard and Arduino. However, since we are aiming to make all the components fit in the base, it's going to require us to think about how to make the circuit board using limited space. You can either follow my model or make your own. I personally think it would be a great time to have students work together to see what they come up with and draft some ideas. Now, I'd like to make 1 row for the positive terminal and the row on the other side of the board for the negative terminals. I'm going to start with the transistor and placing it in the center of the circuit board. Make sure you know your pin order. 1 is the base, 2 is the collector, and 3 is the emitter. We will need to place a 220 ohm at pin 1. Pin 2 needs to connect to the rectifier diode. However, unlike a resistor, which doesn't matter which direction the current comes from and goes, a transistor does matter. Look closely at your rectifier diode and you will see a gray line. Connect the side with the gray line to the pin of the transistor. Then the other side of the rectifier connect to the ground strip. Then we are going to connect pin 3, which is also connected to the ground strip. Take the other 220 ohm resistors and place them on the empty rows of the circuit board. These are the resistors for the LED lights. Now let's wire up the potentiometer. We're going to begin by soldering on the positive and negative cables. Finally, we're going to solder on the control wire, which is the middle pin, and it will attach to pin A0 on the Arduino Nano. With the wires soldered, let's go ahead and put the potentiometer in the base. Simply slide it through the hole and make sure you use the nut to tighten. Now we need to solder the two wires to the DC motor. Most motors will let you know which is the positive and negative side of the motor. Once soldered, gently slide the motor down into the cylinder. Pay attention to the holes at the bottom. They are there to route wires out and into the circuit board. Next, we have to do the LED lights. If you look at the LED lights, you're going to notice that they have two legs. One is longer than the other. That indicates the positive side. We're going to go ahead and solder the positive side to the actual 220 ohms resistors that we've already soldered onto the board. Then we're going to go ahead and solder the negative side of each light onto the negative terminal of the circuit board that we've designed. With that being said, let's go ahead and connect the LED lights to the actual Arduino. Look at your Arduino Nano. We're now going to connect the green LED to the digital input 8 on the Nano. Then we're going to make the red connect to digital input 9. Next, we're going to connect the transistor to the actual Arduino, and the first pin will be connected to digital input 3. Now, after we have the transistors connected to the circuit board and that connected to the Arduino, let's go ahead and finally connect the potentiometer to the circuit board. Your positive cable will connect to the positive strip on the circuit board, and your negative wire will connect to the negative strip on the circuit board. Let's go ahead and make sure that we connect our positive terminal of the circuit board to the Arduino at a 5-volt input, and the ground input, which is the negative, connect it to a ground input on the Arduino. Now that we have everything wired up, let's go ahead and place it into the base very carefully. So it's time to start inputting the code for the Arduino. I've provided the code, which is in the description below. However, when using the Nano, you must go to your libraries and update it so you can download the AT328 driver, so it can be recognized under one of the COM ports. Now that the Arduino has been connected and is identified, let's go ahead and put the code in. We're going to compile the code. It looks good. We're now going to upload it to our board. This code is a perfect chance for your students to experiment with the potentiometer speeds by modifying the code. If you look at the code, you're going to see the variables for the potentiometer. You can modify these parts of the code so you can make the motor run faster or slower depending on which way you turn the potentiometer. Now with the code loaded, it's time to mount the table base to the motor. Simply align the shaft of the motor and the motor plate and push down. With the actual motor and motor plate attached, you will need to construct a base using some foam board and a circle template. Generally, the template you use should be around 8 through 10 inches in diameter. I'm going to use a lid to an old pot. Lay your template on the foam board, use a small utility blade, and cut around the template. Caution, do not let students do this unsupervised. Now that we have the foam board cut out, use a glue stick and apply some glue to that plate we just attached to the DC motor. Then stick the foam board to the mount. Try to align it as best as possible. And there you go, a nice small round table for your students to build. If you have any questions or comments, be sure to leave them below, and as always, thank you for watching.